Welcome. It's another Tuesday, time for another live stream. And I'm excited today because I get to introduce to you a feature that has been highly requested by customers over the years. And with the recent release of Cscape 9.9 Service Pack 4, we've had a chance for the first time to introduce this feature, and that is simulation. So joining me today is Mr. Casey Gardner. How are we doing today, Casey?
Hey, not too bad. How's it going, Chuck?
It's going great. And as I just mentioned, at Horner, probably, 80%, I didn't mention this part of it, but about 80% of the things that we release feature-wise are requested by customers. And today is definitely no different. Today we're going to be talking about simulation or logic simulation, definitely a highly requested feature for sure.
Yeah, we've really been able to put a lot of those requested features into, especially the last couple of service packs, and kind of flush out a lot of those feature requests that we've been meaning to get to. Some of the recent things we've added is like a migration to tag-based from our register-based logic over to our tag-based logic, DHCP and DNS support. I don't know, we increased some limits for some of our features that just based on customer feedback, such as our alarms, where we went from 1,000 alarms to over 2,000 alarms, and we went from 30 screen objects to 100 screen objects on some of our micro OCS lines. So a lot of good stuff we've been able to take from customers and help implement it, especially here recently for sure.
Yeah, absolutely. And there's no question that there's more to come for sure. So, we've all been anticipating Cscape 10, which isn't available yet, but it's coming. And we've had a lot of requests that we've been able to incorporate with that release. For instance, we got a lot of requests for enhancements for our trend objects. They want us to support more pens, not just 4 pens, but let's say 16 pens per trend. The ability to support multiple data types, not just integers, but also floating point and double integers. So all those things are done as soon as Cscape 10 is released. So we'll see how long that takes. It's been quite a project so far. Casey will be manning the chat today. And if you have any questions, don't hesitate to ask. Just chat those in. Casey will answer them if he can, or he may be saving those till later in the show when I bring them back in, after we talk about simulation. Okay, let's get right to it. So today's live stream is all about simulation. And before we get to the details of that exciting new feature, we're going to start with a quick review of the Cscape logic options, because there are more than one. All right, and that's an important factor when we talk about logic simulation. We're going to talk about our standard IEC languages along with our enhanced IEC languages. And what are our enhanced IEC languages? Well, one of the things you get with enhanced IEC is you get logic simulation, variable setting and monitoring during the simulation process, the ability to set breakpoints and trace points. And of course, after we talk about all those things, we're going to spend most of our time with a hands-on demonstration, because that's what makes these live streams valuable for sure. Okay, let's talk about the Cscape application development process. So Cscape software is used to configure every aspect of the Horner OCS all-in-one controllers. And if you're not familiar with our OCS all-in-one controllers, these are products that combine the functionality of a PLC with an operator interface, built-in I/O, and the ability to add expansion I/O, along with extensive networking capabilities. Well, with all those product capabilities, all that has to be set up. And Cscape software is the tool that we provide to our customers to do just that. So within Cscape, you can configure the logic programming, the I/O configuration, all your operator interface and screen development, as well as all the setup for networking, including the configuration. So again, every aspect of OCS configuration is performed with Cscape. Now, when it comes to logic, we give our customers multiple options as to the form of the logic programming that they want to do. Now, originally, when the OCS was released more than 20 years ago, and there have been countless improvements since then, but the original language available was Advanced Ladder. That was register-based. What that means is that every time you add a variable to your program, you need to map that variable to a specific memory location in the controller. Now, unlike a lot of companies that have effectively made that programming scheme unavailable, we have left it as an option for our customers. If they want to stick with that, they can. Okay, and today, it's still the most popular approach for logic programming. More and more of our customers are moving towards variable-based languages. A lot of them are looking at variable-based advanced ladder. It's identical to our traditional advanced ladder, but now a bulk of the variables you create do not need to be mapped to specific memory locations. Exceptions to that would include real-world I/O and maybe some, let's say, communications type variables that might be mapped to Modbus or something. And then even additional customers are migrating towards IEC languages. Those are the standardized set of 5 IEC languages that we've had available from Horner for a while, including ladder logic, structured text, function block diagram, sequential function chart, and instruction list. And with the IEC-based languages, we've actually been offering those for many years, and we have a relatively small but loyal group of IEC programmers, and that group is growing quickly. Okay, so again, standard IEC has been available for many years. It's compatible with all Horner controllers from the very beginning. Now, it does have some restrictions or some limits. It's limited to 10,000 variables. There are 64,000 total of variables in a lot of OCSs. With standard IEC, you're only going to have access to the first 10,000 of those. And you do pay a bit of a speed penalty because it is executed at a slower scan rate than advanced ladder with the standard IEC. Okay, and again, as I mentioned before, we have a relatively small but loyal customer base that is definitely growing. And one of the reasons it's growing is because more and more engineers are coming out of college familiar with text-based programming languages like C, for instance, or C++. And included in the group of programming languages with IEC is structured text, which is a text-based programming language. So a lot of new engineers especially like to gravitate towards that language. Now, ladder logic's not going away anytime soon, but the advantage of being able to choose different languages for different parts of the machine logic is significant. Now, because we have so many loyal IEC customers and they've been looking for feature additions and improvements and those sorts of things, we've been really able to deliver those with Cscape 9.9 Service Pack 4. For instance, you're no longer limited to 10,000 variables. With Enhanced IEC, available with Service Pack 4, we can support the full 64,000 variables. And there's no longer a performance hit. You get the same performance that you get with Advanced Ladder. Now, again, Enhanced IEC was released with Service Pack 4, and keep in mind, it is a licensed feature. Okay, now it does cost $50 per unit typically to license a unit to support Enhanced IEC. Now, the good news is, for the next couple months, we're going to continue to give away vouchers so that you can take whatever OCSs you have in your possession for the next couple months, and you can license those permanently to support the Enhanced IEC and get a lot of those new features that come along with it. And actually, in the comments section on YouTube for this particular live stream, you will find a copy of that free voucher. And that voucher is going to work for multiple OCSs for the next couple of months, and it's going to allow those units to be permanently licensed for Enhanced IEC. And then a couple months from now, once we start charging, then you'll need to purchase licenses at $50 US or purchase vouchers at $50 US to take advantage of the feature. But what do I get with Enhanced IEC besides the capacity and performance enhancements? Well, you get a host of new features, including online programming, so that you can change the program in the controller, the logic program in the controller, without stopping the controller. That's a big deal to a lot of people. You get the simulation feature that we're going to cover in tremendous detail today, and you get a variety of other things, including additional data types like enumerations, improved exception handling, and a whole bunch of other things. Now, one thing to keep in mind, and that is the Enhanced IEC is only compatible with a subset of the Horner products that are available today. Now, it's compatible with a lot of them, but a subset. So all the RCC units, except for the 6512 high-speed coprocessor, the X5, along with the XL4 through the XL Plus 15-inch. Those are all compatible with the Enhanced IEC. From the standpoint of the micro OCS, with the exception of the X5, and the XLE and XLT, those do not support Enhanced IEC, but they continue to support standard IEC, just with lower capacity and without some of these new features. Okay, now we're going to dive into the simulation and debug capabilities that we've released in Service Pack 4 along with our Enhanced IEC package. So what is simulation? Well, as it sounds, it basically allows you to test your program logic directly in our Cscape software without having to have a controller connected. Okay, so that's the big deal there. And it's a rich feature set. As part of the simulation, you get step-by-step execution, line-by-line execution if you want to do that. You get cycle-by-cycle execution, which is basically scan by scan. So you can execute one scan at a time if you wish. You can set breakpoints, you can set trace points, and we'll go into a lot of detail about what those are and what their advantages are further on down the line. And as a matter of fact, let's dive into the simulation demo right now. So I'm going to go ahead and switch over to Cscape. All right, and what do I have here? What I have is Cscape 9.9 Service Pack 4, and I have opened a IEC program. But the first thing I want to show you is how you can set up your version of 9.9 Service Pack 4 to support Enhanced IEC. What do you need to do that? Well, there's just a couple simple steps. The first simple step is you go to the Tools, Application Settings area, and down here under Supported Program Types, you make sure that Support IEC Editor Programs as well as the Enhanced IEC Default Enable checkboxes are enabled. So what that means is this: when you open a new program from scratch, it's going to ask you what type of logic language you would like to use, and IEC will be one of the choices. And then by checking this Enhanced IEC Default, it basically means that if you're configuring a controller that supports Enhanced IEC, like an XL4 or an XL7 for instance, then it's automatically, Cscape that is, will automatically utilize the Enhanced IEC feature set. Okay, so that's what you need to do primarily. Okay, those two checkboxes. Now, the other last thing, again, is you need to make sure that you've configured or that you're configuring a controller that supports Enhanced IEC. In my case, I've got an XL4 I'm configuring with this program, and absolutely the XL4 does support Enhanced IEC. Okay, so I'm all set. All right, so what have I got here with this program? I've got a simple bit of ladder logic. Now you'll notice that the ladder logic looks a little different than what you might be normally used to seeing in the advanced ladder from Horner, and that's because with the IEC package, we have very closely followed the IEC specification. So we've tried to make it as standardized in appearance as possible, in addition to the standardized programming language and standardized function set, if you will. So I've got a routine of some simple ladder logic. I've also got a structured text routine. Okay, we'll go through that here in a little bit. And then I've also got a subroutine that happens to be written in structured text as well. Let's go back to the ladder section and take a look at that. So what are we doing here? Well, as often when it comes to Chuck Ridgway doing demonstrations, it's a start-stop circuit because everybody understands those, right? And then in addition to the start-stop circuit, we've got a timer where we are timing how long the motor is running. And then if it runs for a certain amount of time, then we effectively are going to automatically stop it. That's what I've attempted to program with this. And you'll also notice that with some of these contacts here, you will see some mapping has been done of some of these contacts because they are connected logically to a real-world I/O point. So those mappings need to be done. So let's go ahead and just see if I program this properly and see if this works the way we anticipate. And I'm going to use this simulation, start simulation button here to do that. Now another option I have under the debug window is I can press start simulation there as well. But let me go ahead and press start simulation. So what you'll notice is suddenly I now have status for each of the variables, true or false. Okay. For the timer and counter, I have the preset current value and the accumulator current value. And down here in my variable window, I also have current values for all my variables as well. So that's pretty convenient. So it's a start-stop circuit. Let's see if we can start our motor. So what I'm going to need to do here is to push the start push button. So I will do that by double clicking and hitting true. Okay, and as soon as I do that, nothing is happening. All right, oh, well that makes sense. We know why nothing is happening. I've got power here, but no power there. All right, so let me let go of my start push button and let me go ahead and make sure my e-stop circuit is passing power. Okay, so I should be all set now. Let's go ahead and double click here and hit true. And holy cow, I've got problems. My motor starter is clicking on and off. Why is that? Let's see. Well, it looks like this bit here is flipping on and off. That's coming from here. Uh-oh, I forgot to set the preset for my motor timer to a value that's non-zero. So that's not going to work. So let me go ahead and set this start button to false again. And then the stop preset variable is the one I need to change. So let's go down here to the variable list, double click, and I'm going to type in a value for that. Now this is in tenths of a second based on the type of timer that we've got there. So now my motor timer is set for a preset of 100, which is 10.0 seconds based on 100 millisecond time base. Okay, now let's see if this works as we expect. So I'll go ahead and press the start button. That started, that's good. I'll let go of the start button. The motor is running. We're timing up, and after 10 seconds, hopefully, yep, sure enough, we've broken power. So, okay, so it looks like I've mostly tested this logic. I can also double check and make sure these stops are working. Well, we know the auto stop works. We know the e-stop works. We could double check this, but that's just a normally closed contact. There's no issue there. So I think we've pretty much fully debugged our ladder section. And there's a lot more complicated sections of ladder that you could diagnose with the simulation feature. Now let's go back and take a look at our loop here. All right, and I'm going to go ahead and get out of simulation mode so that, and then quickly go through what this loop is doing, and then we'll go back into simulation mode. So really all we're doing here is we have a simple variable called loop count, and we're incrementing that from 0 to 100. We stay in the loop until we hit 100. At that point we fall out of the loop, and it looks like we set this variable to be equal to the output that we receive from this subroutine called stcalc, which is down here. Okay, so that's what's happening, and then as soon as we get done making that calculation, we reset our loop counter to 0 and we redo the whole thing over again. So let's go back into simulation. It's taken us to the first thing that's executed, which is the ladder. Let's go over to the loop and watch what's happening, and sure enough, our loop counter is incrementing from 0 to 100. That all looks good. Now we haven't really tested our subroutine yet, but let's just go ahead and move on to some other features in simulation that's going to make it easier to test out that subroutine, for instance. Okay, so I'm going to go ahead and get out of simulation mode, and then let's go back to our slides and continue on with some of the additional features that we have with simulation. And let's start with breakpoints. We have the ability to add breakpoints when we're doing simulation. So what are breakpoints? Well, those are flags that you can set that set points in the program where your logic can be paused while you're executing, and that can be anywhere that you choose to put that. It can be within a subroutine, it can be within a main loop, it can be in a ladder loop, it can be in structured text. There are, I believe, I think you cannot put breakpoints. I don't think those are supported in all the languages, but certainly for structured text and for ladder, those are fully supported. And then we also have a feature called trace points. Now trace points are placed in the logic as well, but those don't cause the logic to be paused. They actually cause a timestamp to be created every time that logic is executed. So that can provide with solid evidence that yes, that logic did actually execute, even though you don't pause in the middle there like you would with a breakpoint. After you set these breakpoints and trace points, but especially with the breakpoints, you've got a whole series of commands you can use to really customize how you work your way through the program, either line by line, scan by scan, etc. So let's start with the cycle by cycle button. When you're in simulation mode and you're in cycle to cycle mode, you effectively are going to run until you get to a breakpoint. Okay, so if you put a breakpoint in and you're in cycle to cycle mode, you execute, Cscape hits a breakpoint, it stops and pauses effectively at that stage. Okay? Now, single cycle mode is a little different. Single cycle mode is a way of executing a single scan. So no matter where you are in the logic, it's going to execute one scan through the entire program. Okay? And then there are some additional options as well. Let's say that, yeah, it's useful to be able to execute to a breakpoint, and yeah, it's useful to be able to go one scan time through the program, or one scan through the program, but what if you want to go line by line, or instruction by, or line by line effectively? Well, that's where the step in capability comes in. You press that button, now you're effectively going to be executing line by line as you press that button. And then there's a couple other buttons that are useful when you're dealing with subroutines. There's the step over button and the step out button, and I'll demonstrate those for you to kind of show you how those can assist when you're troubleshooting your subroutines. One last thing, and that is, in addition to these trace points and breakpoints and the ability to tightly control how you work your way through your program, we also have some debug windows that are available where you can see at a glance the list of breakpoints and trace points that you've put in your program. You also have what's called a runtime window that shows you the timestamps for each of the trace points that you've hit during simulation mode. And then there's also a call stack window. So if you are in step-by-step mode, it will show you specifically what routine is running and what line in that routine is running. And if that routine calls a subroutine, or a UDFB for instance, it will also show at a lower level what line of the subroutine is being executed. And then once that's complete, of course, then it'll go back up to the routine that called the subroutine. So that can be really useful for taking a look at how your instructions stack up, or how your calls stack up from your main line code or your main routines to your subroutines and your UDFBs and all that sort of thing. So those are all great tools for being able to simulate and debug your program. Now it's time to take a look at the debug capabilities. So let's go back to Cscape. So now let's take advantage or take a look at breakpoints and trace points. But let's start with the breakpoints. So let's go ahead and put a breakpoint somewhere here in our structured text loop. And I think a really good point to put that breakpoint would probably be right here. This is the point at which we fall out of the loop. Okay, so we've looped from 0 to 100. Our value of our loop counter equals 100. So now we fall out of the loop and we execute this assignment command, which effectively calls the subroutine. I think that's a great place to put a breakpoint. So I'm going to make sure the cursor is on that line, and you can see it there. I'm going to right click and select Add Remove Breakpoint. And you'll notice that F9 would be another option to be able to do that as well. Okay, there we go. So now what I've done is I have put a breakpoint in the code right there. Let's go into simulation mode. All right, so now I'm in simulation mode. Again, it started out by showing me the ladder logic, right? It started executing the ladder logic because that routine is listed first, so it executes before the loop. But then as soon as it hit that breakpoint, which it did when our loop counter equaled 100, then again it hit the breakpoint and it paused. All right, so what's happening now? Well, our program has paused. And the next thing that's going to be executed is we're going to assign a value to the variable motor amp, which is going to be the result of a calculation that the subroutine makes, this subroutine here, on this variable, motor AI. Now, motor AI currently has a value of 0, and that's not very, it can be a useful value, of course, when you're doing simulations, but let's give motor AI a actual non-zero value so that the calculation will be a little more interesting. Okay, so I'll make that 100, value of 100, hit enter. All right, so now this is the value that will be passed to the subroutine, and then that subroutine, when it gets executed, and we haven't hit go yet, when that subroutine gets executed, it's going to take the value in, it's going to multiply it by 2.54, and then it's going to return that value back. So let's go back here. So what I'm going to show you first is I'm going to say, hey, let's just go ahead and run again to this same breakpoint. Okay, so we should continue executing after I press this button. It should go ahead and call the subroutine, make that calculation, return from the subroutine, and then go back until it hits the same breakpoint again. So let me do that. All right, I hit go. You can see that it did indeed make that calculation, and then it reset the loop counter to 0 and then counted back up to 100 again. So there we go. So I could go in here under Motor AI, set it to a different value. Okay, execute another loop through. It came up with a new result, and again, broke at this point exactly. Okay, so that is the ability to effectively execute until you hit a breakpoint. All right, now let's go ahead and take a look at kind of a scan by scan capability, which is capable with this button right here. Okay, executing what they call a single cycle, which is effectively a single logic scan. All right, so I'm going to press this button and see what happens next. Okay, keep a look at my loop counter and where I am in the logic. I'm going to go one complete scan of the controller, and you'll see that on that one scan, the most visible result is my loop counter was reset to 0. Okay, I'll go another scan. You can see, okay, I'm looping up 1. Every time I press this, I'm executing another scan, another cycle, if you will, and we're counting up towards 100. Okay, and I'm doing this one at a time. Okay, that's pretty useful. So it allows me to see what's happening on each loop every time through the loop as I'm counting up. So that's the single scan capability. Now let's go ahead and take a look at the single instruction, or the single line, or the step by step. Not the scan by scan, but the line by line. Let's move line by line through the program, and that we do that with this button here. This is the step in button. So I'm going to go ahead and press that, and it effectively moved me to the next thing it executed, which was the first line of ladder code. So as I continue to press this button, it continues to go through everything that is being executed line by line, so I can examine if the flow is happening the way I expect, if every individual instruction is executing the way I'm expecting, etc. So this gives you the capability of executing line by line. Again, very handy. Right now we've worked partway through our loop, going on the way to 100. The next thing I want to show you is kind of some debugging on our subroutine, how we can control the stepping through our program when we've got a subroutine involved. Now, to make that easier, instead of hitting the scan button another 88 times, I'm going to go ahead and cheat, go down here to loop counter, get it up to 99. Okay. And now I'm going to go ahead and go instruction by instruction. Okay. All right. So I'm continuing to work my way through line by line, not instruction by instruction, to be more precise. Now I've gone up to 100. Now I'm ready to fall out of my loop. Okay, so if I continue on, yep, here I've fallen out of my loop. The next step is to enter the subroutine. Now if I press this step in button, all right, it's actually going to step me into the subroutine. So here we are, that's the structured text calc subroutine. So literally, as I press this step in button, I can work my way through the subroutine, and it will execute, okay, and then return back to the point at which, or to the line after the point where the subroutine was called, which is what it's done here. Okay, very good. Now let's just go ahead and do a complete cycle through. Okay, now we're sitting again with another full cycle where we went through and got our loop up to 100. Now let's take a look at a slightly different approach to handling the subroutine. So last time, if you remember correctly, I pressed the step in command. This time I'm going to press the step over command. So what's going to happen here? Well, let's take a look. Okay, so I'm sitting here on the crux of calling the subroutine, on the verge. I press a button. It basically didn't show me the subroutine at all. it effectively, we had the result of the subroutine, which was probably hard to see. We'll do it again. But it effectively didn't show me the subroutine. It just took me right to the place where we returned from the subroutine. All right, so let's go ahead and do this again with not a new loop count, but with a new motor AI. Let's set this to a different value so we can see the result. All right, let's run through the loop one more time. Okay, and now let's press once again, instead of step in, let's press step over. It executes the subroutine. You could tell that by this value changing, but it didn't actually take us into the subroutine. Okay, so that's another way when you're stepping your way through your program. If you really don't care of going into the subroutine, you just want to execute it, then the step over button allows you to do that. Okay, so that's another option you have. And then let's take a look finally at this step out function. All right, so let's change the value of motor AI so we can see the result. All right, let's do another cycle so we can get our loop back up to 100. All right, now let's press step in to get into the subroutine. All right, and then let's press the step out function, which effectively will step us through and then ultimately out of the subroutine and then back into our main logic, in this case back to the ladder logic. Okay, so hopefully this demonstration has illustrated some of the tools that are available for breakpoints. All right, well, the next thing I want to show you are trace points. All right, and before I do that, I'm going to pull up a couple of available windows that can be used when you're in the debug mode. So I'll go to the debug menu here, and under debug windows, I'm going to enable all three of these. We're going to have a call stack window, we are going to have a breakpoints window, and we're going to have a runtime window. All right, and those are all shown here at the bottom of the screen. Let me move those over so we can see those better. Didn't get all three of those. Why not? Let's take a look here. Let's go back to debug, go back to breakpoints. There we go. I must have had a bad mouse click there. My apologies. And now we need the breakpoints, call stack, and let's go to runtime. There we go. Now we have all three. All right, so let's start with the breakpoints. So this window just shows you the list of all the breakpoints and trace points that you have in your program. That can be useful, especially if you forget where they are. If you double click on any one of them, it'll take you to that part of the code where it's located. And then the call stack can be really useful. Let's go ahead and show you that real fast. So let's run another trip through our loop, okay, to our breakpoint. All right, there we go. And it shows you, as you can see, it shows you where you are in the logic. So we're in the ST loop routine on line 4. And then if I go step by step or line by line, it shows me, yep, I've called the calc subroutine and I'm on line 2, and that was called by the ST loop line 4. So as I continue to step through that, you'll see ultimately, okay, as I'm stepping through, that I go back up to line 5, which is the line after where I called. So call stack can be really useful, especially if you have multiple levels of routines that you're dealing with. Now the last thing I want to talk about are trace points. All right, and trace points are unlike, I guess what you could say, unlike breakpoints where you pause at that point in the logic. Trace points are where you simply make a time and date stamp happen whenever that part of the logic is executed. So let's go into our loop, step calc loop, and let's go ahead and add a trace point right here on line 3. So I've got the cursor there. I'll right click and say add remove trace point. You'll notice that that's a square instead of a circle. That's how you know the difference between a trace point and a breakpoint. And when I go back here to the breakpoint window, you'll see that both the breakpoint and the trace point that I put in already are both listed here. All right, now let's go back to our runtime window. No timestamps here yet, but let's start executing a cycle of our logic. Okay, cycle by cycle, and there you go. You can see every time we call that subroutine, we pass that point in the logic, and even though we're not pausing in that subroutine, we have effectively proof of exactly when we reached that particular trace point. Okay, so those are the debug windows that are also available. The call stack to help you keep track of the different calls and the different levels of code that you are executing. Breakpoints with a list of your breakpoints and trace points, and the runtime window, which shows you the timestamps for all your trace points and when that logic was executed. Okay, so let's go ahead and bring Casey Gardner back in. All right, Casey, so that is simulation and debug in the Advanced IEC. So any questions or confusion there on anything I showed, do you think?
I don't think as much regarding what you showed. We had some other questions come in just kind of regarding some of the IEC or variable-based features specifically.
Okay.
One of which was for structured data types, and if we could use it in arrays, which we can. For variable-based, there's no option to need to enable it, but in IEC, I had actually forgotten, our friend Mark actually pointed it out that there's a specific checkbox in the editor options within Cscape to enable structures for arrays for structures. So that definitely has to be enabled.
Let's go ahead and show that real quick. Excellent. Okay,
Sure.
let me flip back to Cscape. All right, here we go. And let's go ahead and show where you can set that checkbox. Thank you, Mark, for reminding us. Okay, so I believe if you go under Tools, oops, we got to get out of debug mode first. When you're in, not debug mode, get out of simulation mode first. When you're in simulation mode, you need to get out of it before you can get at a lot of the menu items. Okay, so let's go to Tools, and instead of going to Application Settings, let's go to Editor Options, and then under the Compiler Options, we have a checkbox that says Support Array of Structures. Good point. Okay, so and we get a little bit of a warning saying this does cause some performance hits. Okay, so just good information there. So that's obviously important if you're using that feature. But yes, unlike the variable-based advanced ladder, with the IEC, to support arrays of structures, you need to check that checkbox. So yeah, thanks for Mark for pointing that out and getting us to show where that is. I'll bring Casey back in now. All right, any other questions that came up?
So another question that came up is more, I think, of just a general question for whether it would produce an error within the PLC.
Okay.
And it's probably hard to say without actually testing it.
Okay.
Our Alfredo had a question asking if I use 4 do commands, for example, of index 0 to 500 by 1 do, would this produce an issue?
So is he talking about nested do loops? Is that, you think, what he's talking about there? Or I'm assuming that's what he's talking about.
It might be. I think that's kind of the route he was taking.
Okay. You were right. That's one we should probably check on offline and get that answer answered and get him answered there. So, and let's also remember to post the answer, at least textually, on the comments for the comments for the video, for sure.
Well, you can do that.
Okay.
Other than that, let me check. I don't think we've got any others coming in, so I think we're good.
Okay, very good. All right, so I'm excited to start using more the simulation feature for IEC. And yes, we are working on simulation for variable-based ladder. I don't have a specific version where it will be released, but it's a high priority request for not only the enhanced IEC, which we've already delivered, but also for variable-based advanced ladder. So keep your eye out for that. We will be delivering that relatively soon. Well, soon is a relative term, right? Okay, let's take a look at next. Let's not forget to mention the fact that every Tuesday we have a new live stream available for you. And whether you can watch them live and be able to ask questions, or whether you're going to watch on replay, they're always available on our YouTube channel. We're excited for next week. This was a request of one of our loyal OEMs, okay, that basically came in to visit the factory a couple weeks ago, and they had some questions on security in Cscape. When we're talking about security, we're specifically talking about securing your logic. If you're an OEM and you are selling a machine, you don't want anybody to be able to, effectively copy your logic or to change something in the logic which might be unsafe. You want to be able to secure your intellectual property to protect the machine, to protect your business, and to protect your customers from unauthorized changes. And we're going to show you the different ways of doing that in Cscape next week. So that'll be great. Also, we'll be giving you a lot of details on this coming up in our July newsletter and on our website. But here's our July schedule. So in addition to the Cscape security, we've also got a session on user-defined function blocks with Advanced Ladder. We're going to talk all about J1939 protocol. That's the CAN-based protocol that is present in all kinds of industrial equipment, all kinds of mobile equipment, and it's supported by the OCS, which unlocks all kinds of great applications for that. And then we're also going to talk about the analog I/O in the micro OCS in a session. So we'll be covering things like, how do we connect RTDs? How do we connect 4 to 20 milliamps? How do we do field calibration? Because there's a field calibration feature built into the micro OCS that I don't think we've ever really reviewed in any kind of detail before, and I think a lot of people don't really know it's there. Those are all what's scheduled for July. So don't forget that every Tuesday, join us if you can, or check out our YouTube channel for the replay. Thanks again to Casey for keeping an eye on the questions. Thanks again for Marcy in the background for keeping things set up and rolling. And we look forward to seeing you all, hopefully next week, for our next live stream. Take care.